Hello, everyone. Very nice to be here. Such a lovely crowd. So before we start our talk and introduce what data observability is and what is it we're trying to achieve with Sifflet, I just want to ask quick questions to the audience if you want to play the game. Who here has ever suffered from a big data quality problem at their organization? OK, a few people raising their hands. Who here has an idea how much their company is spending on big data and infrastructure? And can share? OK. Last question. Who here has ever had somebody from the business call them on a weekend or off work hours questioning something about a data science model, a dashboard, or something like that for data in production? OK.
I've called people, if that helps.
You called people. All right, great. I'll introduce myself very quickly because that gives also the background of why Sifflet came about. So my name is Salma Bakouk. I'm CEO and co-founder of Sifflet. Before Sifflet, I was in your shoes. I was a data practitioner. I actually built a data platform from scratch at a Fortune 500 company, a US bank. We did the whole thing, moving from on-premise to the cloud. We had a data mesh even before data mesh was a thing. This was 2017. We had a very fancy data stack. We were one of Snowflake's biggest customers. And then one day, we had a data quality issue that cost the company $20 million. So that was the start of a lot of research and what led me to start Sifflet. So as I'm sure you're all familiar, the modern data stack or the data stack in general is only getting more and more complex because your business stakeholders, the decision makers, your board of directors, regulators, everybody's so hungry for data that they're asking data team for all sorts of things, right? And everybody thinks that more data is good, it creates differentiating edge, but in reality, if you don't have anything that can help you keep track of that data, more data is actually more problems. Now, this was basically the questions that I asked in the beginning. I wanted to get an idea of who was in the room and how painful it is, data quality for you guys. And I think we can all relate to a lot of the people here on this slide. And on the topic of data quality in general, it's not something that is new. It's something that we've all suffered from. A lot of organizations suffer from it at different stages and different scales. But what we can all agree on is that it's a big problem, and it's a lot of time wasted, time that could be invested doing something better. Who here relates to these percentages that were done by Gartner on the amount of time that data engineers and data consumers spend on data quality? Awesome. I'll tell you what, we actually checked these numbers with pretty much all the customers and all the partners we work with at Sifflet, and we see something pretty much in line. So Gartner is onto something. Now, without further ado, the solution. So this is this new category of data observability. I'm sure some of you have already heard it. I know a lot of technologies have emerged in the space with a lot of promises in trying to solve this problem for both data engineers and data consumers and make data quality something that is, you just come to the office and data is of good quality, right? OK, concretely speaking, and again, as a disclaimer here, I don't want this to be a vendor pitch. The idea is really to explain our framework, how we created it, and hopefully give you some inspiration on how you can get about monitoring the quality of your data assets and achieving better reliability and observability within the data within your organizations. So observability is a concept that comes from software engineering. I'm sure a lot of you are familiar with some of the logos there, Datadog, Splunk, New Relic, et cetera. They created this category with the whole DevOps movement that happened 10 years ago. Now, the DevOps movement is wonderful, but data engineers, unfortunately, and data practitioners, we missed on that movement, right? And the frameworks that these companies built to monitor infrastructure and applications were built around three main pillars. They look at the metrics, they look at the logs, and they look at the traces of each infrastructure to get ahead of application downtime and an application going out of service or something like that and causing something bad for the business. Now, With Sifflet, our approach particularly, obviously you can't just take the framework of observability, and believe me, I tried to do it in the past. I tried to use Datadog to monitor data quality, it didn't work. Data and data infrastructure, as a lot of you can agree with me, is much more complex than software. And actually software and infrastructure is just the tip of the iceberg when it comes to data quality and data quality issues. So our framework with Sifflet is built around 4 main pillars. So we look at the metadata, the data about the data. We look at the logs of the applications, the same way an infrastructure monitoring tool would do, and I'll explain that in a bit. We look at the lineage. How are these assets related to each other? What's the relationship between post, pre-production data? How is the data being fed to the consumer, et cetera? And finally, we look at some metrics that can help us make sense of the health status of the data assets. This is a representation of what the modern data stack looks like today, even though I'm pretty sure a lot of you have a lot of different opinions about the data stack. But this is a simple or pretty simple representation of what the data stack looks like today. Observability, or at least the way we define it at Sifflet, should be a top-of-stack layer that, regardless of what constitutes your data stack, regardless of the use cases that you are using to leverage data, data observability should be the layer that ensures that everything is working smoothly, right? The DNA really behind this is monitoring and ensuring reliability and ensuring sustainability. So concretely speaking, how does that work? And again, speaking from the vantage point of Sifflet, data observability, the way we define it, or full data stack observability, is a top-of-stack layer that connects to your existing data infrastructure and follows the workflow and emulates the workflow of the data within the organization, from ingestion all the way to consumption. Whether consumption is machine learning, data science, reverse ETL, BI analytics, et cetera. And really, the observability tool should have, or the observability framework should be able to give you all sorts of insights so you can get ahead of data catastrophes before they become business catastrophes. Let's go into a bit more detail. And again, this is from the vantage point of Sifflet. Data observability is a category that is under construction. I'm sure a lot of vendors would have different opinions and different views, but this is how we define data observability, and this is how we've seen it play out with a lot of the partners we work with. So first of all, what are we trying to achieve with observability? We're trying to make sure that whenever something breaks within the data, or the metadata, or the infrastructure, data engineers and data consumers are aware. So a big component of ensuring observability of the data assets is to know when something breaks, right? Or in other words, anomaly detection. Anomaly detection can be done in a lot of different ways. You can test your pipelines, you can test your code, you can do some basic data profiling, you can implement some open source solutions. A lot of things can be done there, right? But really, and if some of you are familiar with cybersecurity and all the things or the stories we hear about alert fatigue in that space, alert fatigue can happen when you're monitoring your data assets as well. If you just have testing and monitoring and basic anomaly detection frameworks, it's better than nothing. But as a data engineer, you receive an alert that says, hey, something broke. What are you going to do? You just look at it and you're like, OK, well, fine. Something's breaking again. I'll look into it. I'll add it to the list of a million things that I already have to do, right? So with Sifflet, we wanted to go a step ahead of just sending you alerts and sending you noise. And that's why we built a very powerful data lineage that's embedded in our product. So the data lineage really serves 2 main purposes. Number one, as a data engineer or as a data producer or as an owner of data products or whatever framework you're using internally, depending on how your teams are set up, you want to know where the problem is coming from. Because troubleshooting time is a big waste of time. Data engineers are not just expensive data firefighters, right? So thanks to our lineage, today we're able to give you a very detailed root cause analysis that helps you as a data engineer or a data producer go and point directly to the root cause. This is only possible with data lineage. The second use case for lineage in this purpose of data reliability and data quality is business impact assessment. Okay, in an organization, you have data producers, data consumers, you have platform architects, stuff like that. So a lot of people have different personas and different expectations around the data, right? If the purpose is to make the data reliable, data has to serve a certain purpose for the business. We're not, a lot of companies, most companies are not just in the business of doing analytics for analytics, right? And so with that in mind, our tool, when we built it, we wanted to make sure that it was inclusive also to business users, to data consumers, so that you can actually know how the anomaly is likely to impact the business. Say, for example, it's reporting season, isn't it? We just went through our reporting last week. And everybody's sending dashboards to the board to tell them how the businesses are doing. Public companies have to do it in a public forum, et cetera. And so if, as a business analyst or a data analyst or a data scientist, you're supposed to send something to the board that tells them how the business is doing, if you have zero clue how reliable that data you're sending or how reliable that data you used is for your result that you're sending, then you're really in big trouble, right? So it's very important that the business also has an assessment of what's going on, because breaks are going to happen, but it's very important that the consumer of the data knows how likely this is to impact their workflows. So business impact assessment, a big pillar of our product. And finally, and this is speaking of experience, I was in a very big organization. The data team was 200 people worldwide, and we were just the beginning of our data journey. I think now there might be like 500 people worldwide or something crazy like that. We didn't speak to each other. We didn't know each other. We had no clue who owned which data assets. We would query tables. We had a very expensive data catalog. We would search in that data catalog and find nothing that was useful. So collaboration and having that element of being able to iterate around data assets is extremely important for the adoption of a data-driven decision culture within an organization. So we have that pillar as well included, in the sense that you don't just have a data catalog, you need to know how healthy the assets you are querying in the data catalog are. If we want to just zoom in a bit more about the anomaly detection part, because I know that this is what a lot of people really identify with as soon as you start talking about data quality, like how exactly are you going to monitor the quality of data assets? What do you call data quality? Again, this is speaking from our approach, but a lot of these concepts can be adapted to your own use case with another tool, a competitor of Sifflet, or made in-house, or anything like that. But the principles are relatively the same. So anomaly detection, the way we define it at Sifflet, we look at three main things. We look at anomaly detections at the data level. Who here has ever received an email saying, hey, first name, instead of, hey, your actual first name? OK, I receive those all the time. So that's, for example, that's a very basic data quality issue, but that's something that's within the data level. So that's an example of the things that we can look at Sifflet. There was an incident recently with a big e-commerce platform that sells luxury goods, where on Black Friday they showed prices that were completely unreasonable. That's also a data problem, where having a filter that tells you how the prices are behaving and stuff like that is very important. So a lot of or a big part of the anomaly detection framework we do is at the data level. Second layer is at the metadata level, right? Because let's be honest, all of the modern companies today are relying on at least 10 external data sources. And then on top of that, there is a lot of manipulation that happens internally around the data and a lot of stakeholders. So it's very important to look at things like the freshness of the data, are the assets up to date, distribution of the data, is there anything anomalous about how the data is being ingested, the volume of the data, as well as the schema. Okay? And finally, and this is where our approach with Sifflet kind of stands out, is linking back to the infrastructure. Because if we oversimplify it, a data asset is the result of a job that runs on an application, right? So if you are able to get all the information way ahead in the value chain, then you are likely to be able to detect problems before they actually happen, right? So we look at things at the orchestration layer, we connect to the transformation layer, we test the pipelines, we look at pipeline usability, a lot of other stuff like that, that especially in the current economic environment, where I'm pretty sure a lot of you are thinking about budgets and what are we gonna do next year and how much are we gonna spend on data infrastructure, you wanna know if you're actually utilizing all of your pipelines and if you have anything that's legacy and costing you a lot of compute costs, right? So that's the anomaly detection part. Now, the part of what happens after it detects an anomaly, and this is thanks to the lineage. As I mentioned earlier, one of the main results of having data lineage in the concept of data observability is being able to point to a root cause, right? So you want to have an exhaustive mapping of all the dependencies between the assets so that you, as a data engineer, can go and say, okay, I know exactly where the problem is coming from, and I'm going to fix this, and this is the ETA. Data consumers shouldn't be removed from the equation because more often than not, and I see this happen way too often, the adoption of a data-driven culture, within organizations is halted by a lack of trust because data consumers, because naturally they don't have as many technical skills as a data engineer, are almost scared to use the data assets because they have no clue where they're coming from, how they've been constructed, who's using them, etc. So that's where our incident management and business impact assessment feature comes into the play. It makes data more accessible, or it makes data quality more accessible to more users. And that's it. I think now we can leave it to questions. By the way, we have a booth. Some of my colleagues will be more than happy to do follow-up demos and talk to you exactly about your use case. But yeah, this was my attempt to kind of introduce this concept that I feel is now drawing a lot of confusion and a lot of noise.
Thank you.
Thank you.
Thank you so much.